Good morning students. Today I am going to explain about the interference in thin film by reflection. So in case of interference in thin film by reflection, first of all we have to consider plane parallel thin film. So these two lines can be act as a thin film with a refractive index of mu and thickness of small t. So initially the main concept of thin film is when light is incident on a plane parallel thin film, some portion gets reflected from the upper surface and the remaining portion is transmitted into the film. So here again some portion will be transmitted, it is reflected back into the film by lower surface, after that emerges to the upper surface. So these reflected light beams from the top and bottom surfaces of the film superimpose with each other and producing interference pattern and form the bright and dark fringes. So first let us consider it is a monochromatic light ray. AB is a monochromatic light ray incident at an angle of I on the upper surface of the film. So here BE or the reflected ray and BC or the transmitted ray. Here the angle of refraction is small r. The ray BC will be reflected into the film and emerges to the film. After that it will be form the light ray DF. It is the light ray 2. Here light ray 1 or BE. So light ray 1 and light ray 2, both the light rays, the two light rays are superimposed and it is depending upon the path difference between them, they produce the interference pattern. So if you know the path difference between these two light rays, we can draw the additionally DG to BE. So point D to G along the P. From the points D and G onwards, the light ray travel equal distances. By the time the light ray travels from B to G, the transmitted light rays are traveled to from B to C and C to D. That's the equal. So here, mainly our aim is to calculate the path difference between two light rays. So the path difference between two light rays is mu into BC plus CD in film. So BC plus CD in film minus BG in air. So we can consider lower surface minus upper surface of the film. So that can be written as BC plus CD in film minus BG in air. So first of all let us consider triangle BC. So here the triangle BCH. So it is one of the triangle BCH and another triangle is DCH and next another triangle is BGD. There exist two triangles from the lower surface and one triangle on the upper surface. So let us consider lower surface triangle. So from the triangle BCH we can write cos r is equal to HC by BC. So HC is, we know that thickness of the thin film. So here HC is equal to HC, the distance between H to C is equal to, we can consider thickness of the thin film. So that's why HC can be taken as small t. So we can write cos R is equal to HC by BC and BC is equal to HC by cos R, that is equal to T by cos R. So similarly for triangle DCH also can written as CD is equal to T by cos R. And next to calculate BG. So BG will be exist on the upper surface of the thin film. So if you want to know the BG, then first of all you should know the BD value. So from the triangle BD is equal to BH plus HD. If you know the BD value, then we can easily calculate the BG value. So that's why initially we can calculate the BD value. But BD is equal to BH plus HD. So here BH plus HD is equal to BD. So in triangle BHC we can write tan R is equal to BH by HC. But HC we know that small t, then BH is equal BH by T, which implies BH is equal to T tan R. Similarly from triangle DCH also we can write T tan R. So BD is equal to BH plus HD T tan R plus T tan R is equal to 2T tan R. If you know the BD value, then you can easily calculate the BC value. So from triangle BGD, we can write sin A is equal to BG plus BD. Then BG can be written as BD into sin A. That is equal to 2T tan R sin A. Okay, so here R is a refracted angle, I is equal to incident angle. So we can show the both the functions are same angle. So that's why we can use the Snell's law. By using Snell's law, we can write sin A is equal to mu into sin R. So here in the place of sin I, we can substitute mu into sin R. Then BG is equal to, we get 2 mu T tan R sin R. Okay, so now we have all the values from the equation. So the equation is path difference is equal to mu into BC plus CD in film minus BG in air. So now we know that BC value, CD value and BG value. So we can substitute all the values in the equation. So the path difference is equal to 2 mu T cos R minus 2 mu T tan R sin R. Here tan R can be written as sin R by cos R. If you write like that, so we get 2 mu T cos R minus 2 mu T sin R into sin R becomes sin square R by cos R. So we get 2 mu T cos R into 1 minus sin square R. So after then we get 2 mu T by cos R into cos square R. So here cos R gets cancelled. We get 2 mu T cos R. So now the final one we get the path difference is equal to 2 mu T cos R. But at the point of B on the diagram, the reflection will be occurs from the upper surface of the thin film. So that is the denser medium. Generally the light rays are travel from denser medium to rarer medium. So at the denser medium the reflection will be occurs. So because of the reflection, here the light ray 1 undergoes additional phase change of pi or additional path difference of lambda by 2. So that's why we can add lambda by 2 to the actual equation, that is, so light ray 1 undergoes additional path difference, then the total path difference can be written as 2 mu T cos R plus lambda by 2. So here the interference can be divided into two parts, that is constructive interference and destructive interference. You know that constructive interference means when the path difference is equal to integral multiples of the wavelength, then the light rays 1 and 2 meet in phase and undergo constructive interference. Here the condition for bright fringes is 2 mu T cos R plus lambda by 2 is a total path difference that is equal to integral multiples of wavelength, that is n lambda. Then it can be written as 2 mu T cos R is equal to n lambda minus lambda by 2. So here the common term can be taken as lambda by 2. Then we get 2 mu T cos R is equal to 2n minus 1 into lambda by 2, where n can be taken values from 1, 2, 3 and so on. So this is about the constructive interference and also condition for the bright fringe. Suppose if you take the destructive interference, when the path difference is equal to half integral multiples of wavelength, then the light ray 1 and 2 meet out of phase and undergo destructive interference. So that is 2 mu T cos R plus lambda by 2 is equal to 2n plus 1 into lambda by 2. Here 2 mu T cos R is equal to 2n into lambda by 2 plus lambda by 2 minus lambda by 2. Here lambda by 2 gets cancelled. So we get 2 mu T cos R is equal to n lambda. So this is the final condition for the destructive interference, or this is the condition for dark fringes. So totally this is about the interference in thin film by reflection. So generally what is interference means when two or more light waves are superimposed in the medium. Then according to the superposition principle, the resultant displacement at any point is equal to the algebraic sum of the displacements to individual waves. So algebraic sum of displacement means either sum or difference. So here this modification, the mainly interference means the modification in the distribution of the intensity. The modification in the distribution of the intensity in the region of superposition is known as interference. So this interference can be classified into two types. One is constructive interference, another one is destructive interference. So when constructive interference means if resultant amplitude is a sum of the amplitudes of the two individual waves, then the interference can be taken as constructive interference. That means constructive interference means, so constructive interference y is equal to y1 plus y2. The condition is plus algebraic sum of, that means resultant amplitude is equal to sum of the amplitudes of two individual waves. We can use sum here, SUM. For destructive interference we can use the difference. If the resultant amplitude is equal to difference of the amplitudes of the two individual waves, then that interference can be taken as destructive interference. Then that can be noted as minus. Difference means minus. So for constructive interference there exist bright fringes. For destructive interference there exist dark fringes. So the condition for the constructive interference is path difference is equal to integral multiples of wavelength, that is n lambda. But for destructive interference, path difference is equal to half integral multiples of wavelength. That means path difference is equal to 2n plus 1 into lambda by 2. That is the destructive interference. So now let us see what are the conditions for interference pattern. So the main conditions you can note down here. The two light sources emitting light wave should be coherent. The two light sources emitting light wave should be coherent means the two light waves having same amplitude, same frequency, same wavelength and constant phase difference. So that is known as coherence. At the same time here we are using two sources for interference concept. So the two sources must emit continuous light waves of same wavelength and frequency. Okay, the two sources must emit continuous light waves of same wavelength and frequency. So here the separation between two sources should be small. So the separation should be two sources. Okay, now should be small. At the same time the distance between two sources and screen should be large. So distance between source and screen, if source is here, screen is here, the distance can be taken as large. Okay, now and the amplitudes of the light wave should be equal or nearly equal. So there exist two sources and also there exist two light waves. So that's why the amplitudes of the light wave should be equal or nearly equal. Nearly equal means approximately equal. And here the source should be narrow, the source should be monochromatic. It is the important, the source should be monochromatic. So these are the sustainable conditions to get interference pattern. Now, good morning students. Welcome back to my channel. Before we are going to watch my video, please like, share and subscribe to my channel. Students, thank you for watching. Today I am going to explain about the Newton rings concept. So in this Newton rings, today I am going to explain about what is the experimental arrangement of the Newton rings, what is the formation of the Newton's rings, so what is the theory of the Newton rings. In this theory of the Newton rings, you can determine the determination of the bright and diameters of the bright and dark rings and what is the wavelength of light source. So I will discuss about these topics. This is the experimental arrangement of Newton's rings. So here the plano-convex lens, it is the plano-convex lens L. So of a large radius of curvature is placed on with its convex surface on a plane glass plate G. Here the lens makes the contact with at the point of O. The monochromatic light is coming from the source, that is sodium vapor lamp is used. So the monochromatic light falls on a glass plate. So this glass plate arranged with an angle of 45 degrees with the vertical. The glass plate reflects normally a part of the incident light towards the air film because air is exist between lens and glass plate. So in this air film is formed. So the glass plate G reflects normally a part of the incident light towards the air film. It is enclosed by the lens and the glass plate. So a part of light is reflected by the curved surface of the lens and a part is transmitted which is reflected back from the plane surface of the plate. So these reflected rays are interfere and gives rise to interference pattern. So in the form of the circular rings. So here we get alternate bright and dark concentric circular rings. We can observe through traveling microscope. So these circular rings are known as Newton's rings. So these Newton's rings are exist at the point of contact. So this is about the completely arrangement of the experimental arrangement of the Newton's rings. So another one is formation of the Newton's rings. So for the formation of the Newton's rings exist at the same parameters. Here Newton rings are formed due to interfere between light rays are reflected from the top and bottom surfaces of the glass plate and plano-convex lens. So the formation of Newton rings can be explained with the help of this diagram. So a part of the incident monochromatic light AB is reflected at the point of B. It is glass air boundary in the form of light ray 1. So light ray 1 additional phase change of pi or additional path difference of lambda by 2. The other part of the light is refracted along BC. Then at C, the point is C, it is the point of air glass boundary. It is again reflected in the form of light ray 2 with the additional phase change of pi or path difference of lambda by 2. So as the rings are observed in the reflected light, the path difference between them is 2 mu t cos r plus lambda by 2. The another part is reflected along the point C. Okay now. So it is refracted the point C. Again it will be reflected by the plain glass plate. It will be formed the ray 2. So here we have two light rays, that is ray 1 and ray 2. Okay now. So these two light rays are interfere and producing the alternate bright and dark concentric circular rings. So these rings are Newton rings. So here in previous topic we know the path difference between two light rays, that is 2 mu t cos r plus lambda by 2. But for air film, so the refractive index of air is, we know that 1. The refractive index of air is 1 and refractive index of water is 1.33. If you consider the refractive index of air is 1, then for normal incidence R can be taken as 0 degrees. So if normal incidence R is equal to 0 and refractive index of air becomes 1, then we can consider if for 2 mu t cos r, mu becomes 1, R becomes 0 degrees, cos 0 becomes 1. It is also 1. So we get only 2t plus lambda by 2. So here the path difference, now we have 2t plus lambda by 2. The path difference between the light rays are 2t plus lambda by 2. But we can find out the what is the central spot. For central spot we can consider at the point of contact is if 0. If at the point of contact means 0 means t becomes 0. If t is equal to 0, we get only lambda by 2. Path difference is we get only lambda by 2. So lambda by 2, the meaning of lambda by 2 means of integral multiples of wavelength. So that means the reflected light at the point of contact suffers a phase change of pi or lambda by 2. Then the incident and reflected, both the lights are out of phase here. So out of phase means here the destructive interference will be takes place. So the destructive interference means here the central spot becomes dark. So finally you get the central spot becomes dark. Next, if there exists constructive interference between two light rays, the condition for the bright fringes are n lambda, that is integral multiples of wavelength. So if 2t plus lambda by 2 is equal to n lambda means 2t is equal to n lambda minus lambda by 2. If you solve that equation, finally we get 2t is equal to 2n minus 1 into lambda by 2, where n can be taken values from 1, 2, 3. So this is the condition for the bright ring. 2t is equal to 2n minus 1 into lambda by 2 is the condition for the bright ring. Next, let us see the condition for the dark ring. If the destructive interference exists between two light rays, then the condition for 2t plus lambda by 2 is equal to 2n plus 1 into lambda by 2. So here, if you split into parts, 2t plus lambda by 2 is equal to lambda by 2n into lambda by 2 plus lambda by 2. We get 2 gets cancelled here. Lambda by 2 gets cancelled. We get 2t is equal to n lambda. So here the condition we get 2t is equal to n lambda. So for monochromatic light, the bright and dark rings depends on the thickness of the air film. So for Newton's ring system, the focus of points having same thickness lie on the circle having its center or the point of contact. So we get bright and dark circular rings with the point of contact as the center. So finally we can decide the bright and dark concentric circle exists at the point of contact. Now let us calculate the diameter of the bright and dark rings by using this circle. So here already we know that there exists L be a lens that is placed on the plain glass plate P. The convex surface of the lens is the part of the spherical surface with the center at the point of C. Here capital R be the radius of the curvature and small r be the radius of the ring. It is the small r is the radius of the ring. So here this Newton rings corresponding the thickness is small t. Here we can note the small t. Here we can use the property of circle. By using property of circle, the vertices points is equal to horizontal points. That means NA into NB is equal to NO into NO dash. Okay now. So here we can use this property of circle. After that you can substitute all the values. So for NA value, here the value of NA is equal to small r. If NB is equal to small r, NA is also small r and NO is equal to small t. Okay, and next CO dash is equal to capital R. At the same time C here CO is also equal to capital R. So we can substitute that values. Here we get, so we can write that NA into NB is equal to NO into NO dash. So R into R, NA is R and NB is also R from the diagram. So property of circle, and NO is equal to T. But NO and NO dash, NO is 2R, R plus R 2R minus T we get. So here we get R square is equal to T into 2R minus. So here we get R square is equal to 2RT minus T square. So here, but T value is very small value. If T square is also very small value, because if T is equal to 0.1 and T square will be 0.01. So it is very small value. That's why you can neglect complete the negative term. So we get R square is equal to 2RT only. So if R square is equal to 2RT means here T is equal to R square by 2R. Okay now. So in previously we have solved for bright ring the condition is 2t is equal to 2n minus 1 into lambda by 2 by using formation of the rings. So this is the condition for bright ring. So here we can substitute t value 2 into r square by 2r, that is the t value. So you can substitute t value here, we will get this one. So from this we can write r square is equal to 2n minus 1 into lambda into r by 2. Here r is a radius of the ring. So in the place of radius we can replace the diameter. So the relation between diameter and radius is diameter d is equal to 2 into r. So we can substitute that value in the place of r square. We can substitute d square by 4. So d square by 4 is equal to 2n minus 1 into lambda into r by 2. So which implies we get d square is equal to 4 into 2n minus 1 into lambda into r by 2. So 2 1s are 2 2s are. So we get here t square is equal to 2n minus 1 into 2 lambda r. So the square is replaced to root, then d is equal to square root of 2n minus 1 into 2 lambda r. So if we consider here lambda is constant, r is constant, n is variable, then it can be written as d is proportional to the 2n minus 1. If n becomes 1, if here n becomes 1, we get 2 into 1 minus 1. That is the result is 1. If n becomes 2, the result is 3. If n becomes 3, the result is 5. So the result is here we get 1, 3, 5, 7 and so on. If n is equal to 1, 2, 3, 4 and so on, the result will be 1, 3, 5, 7, and so on. So that is 1, 3, 5 is indication of the odd numbers. So that's why here we can written as d is proportional to the square root of odd natural numbers. So the meaning of this, the diameter of the bright rings are directly proportional to the square root of odd natural numbers. So this is the condition for the bright rings. And let us see the condition for dark ring. Previously you can note down the dark ring is 2t is equal to n lambda. But we know the t value. So here the t value is r square by 2r. In the place of t, we can substitute r square by 2r. So 2t means 2t is equal to n lambda, then 2 into r square by 2r is equal to n lambda. So here 2 gets cancelled, we get r square is equal to n lambda r. Then d square by 4, because r is equal to d by 2. R square means d square by 4. We can substitute that value, d square by 4 is equal to n lambda r. Then d square is equal to square root of 4n or lambda. Then d is equal to 2 root square root of n or lambda. So if you consider r and radius of curvature of the lens and wavelength of light source will be constants, then it can be written as d is proportional to n. If we take the values from n can taken as 1, 2, 3 and so on, the result also 1, 2, 3 and so on. So 1, 2, 3, 4 and so on, that is known as natural numbers. So that's why here we can written as d is proportional to the square root of natural number. So this meaning the diameter of the dark rings are directly proportional to the square root of natural numbers. Okay, so these are the conditions for the diameters of bright and dark rings. And the wavelength of light source can be determined as by measuring the diameters of the various of the rings. So here we can consider diameters of the dark rings only. So let capital R be the, we know that radius of the curvature and lambda be the wavelength of light source. So if we consider only mth dark ring and nth dark ring, we can note down for dm square mth dark ring is equal to 4m lambda r. And for nth dark ring, the square of the diameter is equal to 4n lambda r. So if we do the dn square minus dm square by using by above the formulas are 4 into n minus m into lambda r. So from this equation we can write in terms of lambda is equal to dn square minus dm square by 4 into n minus m into r, where lambda is wavelength of light source, r is radius of curvature, n and m are number of rings, nth ring, mth ring, dn and dm are the diameters of the nth ring and mth ring. So here also we can draw the graph between number of rings and square of the diameters of the rings. On x-axis we can take the number of rings, on y-axis square of the diameters of rings. So if you put the values of number of rings related to diameters, square of the diameters of the ring, so we will get finally straight line. So by using this graph also we can determine the wavelength of the light source experimentally. So this is about the complete Newton's rings experiment, formation of Newton rings, next wavelength of light source. If you like this video, please like, share and subscribe to my channel. Thank you for watching. So let us see one problem on Newton rings. So in a Newton's rings experiment, the diameter of fifth dark ring is 0.30 centimeter and the diameter of 15th ring is 0.62 centimeter. Find the diameter of 25th ring. So in this problem, they have given that diameter of 5th dark ring and 15th dark ring. So find the diameter of 25th ring. First, for any type of problem, first you should note down the what is the given data. So here the given data is diameter of 5th ring and 15th ring. 5th ring is 0.3, 15th ring is 0.62. So determine the determine the 25th ring dark ring. Okay, here 25th D25 is equal to question mark. So what is the corresponding formula? We know that the corresponding formula dn square minus dm square is equal to 4 or lambda into n minus m. So first you can use the 5th and 15th dark ring. After then you can use the 25th and 5th dark ring. So first let us use for D15 and D5. So in this formula n can be taken value as 15, m can be taken value as 5. We can substitute 15 and 5 values. Here we get 15 minus 5 becomes 10. 10 into 4 becomes 40. 40 r lambda. We don't know lambda and r value. You can simply substitute r and lambda as it is. But we know the 15th, the diameter of 15th ring is 0.62, that is 0.62 square. The diameter of 5th ring is 0.30, that is 0.30 square. So it can be taken as equation 1. After that, similarly by using 25th ring, 5th ring, as this formula becomes n is a 25, m is a 5, same. N value will be changed but m is constant 5th ring. D25 square minus D5 square 4 or lambda 25 minus 5. 25 minus 5 becomes 20. 20 into 4 becomes 80 lambda r. So we don't know 25 but we know that 5th ring. So we can simply substitute 5th ring. So that is D25 minus 5th ring 0.30 square 80 lambda r. So it is equation 2. So we can do equation 2 by 1. That is D25 square minus 0.30 square by 0.62 square minus 0.30 square is equal to 80 r lambda by 40 lambda r. So here 80 lambda r by 40 lambda r will be cancelled because here lambda r will be cancelled. 41s are 42s are. So we get that is only 2 value. So the 2 can be written as here like that. So we know that only the value of D25 square. So for this equation completely writes in terms of D25 square. So that is equal to 2 into 0.62 square minus 0.30 square plus this is 0.30 square. So completely this value is 0.6788. Then D25. The diameter of 25th ring becomes 0.823. So it is very simple problem. Okay now. So by using this method you can solve the diameters of the rings. Okay. Students, let us see another problem. So here in a Newton's rings experiment, the diameter of 8th ring was 0.35 centimeter and the diameter of 18th ring was 0.65 centimeter. If the wavelength of light is used as 6000 angstroms, then find the radius of curvature of the plano convex lens. Here So from the given data, they have given that diameter of 8th ring and 18th ring. So 8th ring you can note out 0.35 centimeter, but 18th ring is 0.65 centimeter. So by using this, we can write number of rings, that is for 8th and 18th, and also given that wavelength of light lambda is equal to 6000 angstroms. So for 6000 angstroms, so it will be converted into 6000 into 10 power minus 8 centimeter. So 1 angstrom is equal to 10 power minus 8 centimeter or 10 power minus 10 meters. So note down all of you. So 1 angstrom is equal to 10 power minus 8 centimeter or 10 power minus 10 meters. So already we know that formula. The radius of curvature formula is dn square minus dm square by 4 into n minus m into lambda. So this is the formula, already we know that. So by using this formula you can calculate R value, then so you can substitute all the values. You know the dn square value, so that is 0.65 and 0.35 and 8th ring and 18th ring and 6000 angstroms. If you substitute, so that is 0.65 whole square minus 0.35 whole square by 4 into 8, 18 minus 8 into 6000 into 10 power minus 8. So if you simplify that, finally you will get R is equal to 125 centimeter. So this is the answer. It is the radius of the curvature of a plano convex lens. Okay.